is mapped as the first step. Now let me take the value of element as 10. So here we are going to have 10 inside the data part. So now this is done. New node of data equal to element. New node of next equal to null. This is nothing but I am marking here null. Now the new node is ready. Now we are going to check whether the stack is empty. So as of now I don't have any stack. So it means start is null. Now I am going to make this new node as start. So this will become as start. So we have the node 10 which is pointed by the node as well as start. So we have completed these things. Now let us go with else part. It means now we have some set of elements. So we do need this new node. Now the element value is 50. So we are going to have here as 50. It means you have some stack values. So let me have some stack values. Let us imagine the stack is having some 3 values as 10, 20 and 30. And here this first node is pointed with start. We know stack will insert every element either at the last, right? So it goes on inserting. So now we are going to have this 50 after this 30. So this is how we want to point. How are we going to point? This start should move to this specific node. This node should have a name. In order to bring the name for this specific node, we are going to make this node to be temp. That is what we have did here. Struct node star temp equal to start. So now this becomes temp. Now we are supposed to move this temp to 30. That is, we are going to traverse. So traverse to 30. We are going to put a while loop. It means until we are seeing this null, until this null is visible, we are going to do something iteratively. What we are going to do? Temp equal to temp plus 1. This is nothing but as you do I equal to I plus 1, incrementing by 1. The same way temp is incremented. Temp equal to temp of next. What is temp of next? Temp of next is nothing but this specific node. So now temp is moved from here to here. Now it is checking for null. It is not null. So temp is now moved here. Now it is checking whether temp of next is null. Yes, it is null. Now this question mark is removed and this node is given with the name as temp. So this is now not temp. Now we have got the node value as temp. Now it is easy for us to insert, and that is why we have given temp of next. So temp of next will point to a new node. So this is how the push operation works. Looking into the last operation, that is pop. So pop is nothing but a deletion operation, as you know already with the array implementation. So how are we going to do the popping? So popping is nothing but we require some element in a list. So here we don't want to create any node. Instead we are going to check for not empty. If it is not empty, then only we can perform. So if S, what we are supposed to do? The last inserted element will be removed first. So here the same steps has to be done. Traverse and remove. So how are we going to traverse and remove? Let us see. As we know, we don't want new node, so struct node star new node is not required with the malloc, and we don't want new node of data equal to element, and so these 3 steps are not required. So now let us go with the checking for not empty. So how do we check for not empty? If start not equal to null. If start is not equal to null, it means that you have some data. So how are we going to do? We are going to traverse. So what is the explanation telling about? You have a stack. So you have a stack and there are few elements inside the stack. 30 is an element which is inserted at a last. So 30 is an element which is inserted as last element. Now we are going to remove this 30. So how are we going to remove? We know we are at this specific node. We want to move until the element before. So before this we have to stop, and so we can delete this 30. So in order to do this, we are going to go for traversing. So we require struct node star temp equal to start, right? So this is how we'll have a temporary variable, and now using this I could traverse. So while temp of, see, when we are saying temp of data, we will be having here, right? So temp of next not equal to null as we did before. So this is how we used to traverse. But if you are going to do in this way, as you know, here we will be having temp equal to temp of next. Since we saw the explanation for all these steps, you know that this specific node is now mapped as temp, and temp will be incremented at each and every time, and this node will become temp. What is our objective? Our objective is to remove this node. This 30 is not required. So we require some variable for this specific node. So what we are going to do is, we are going to have another variable called star. Let me write over here. We are going to have another variable called prev. This is also going to point as start. So initially prev will be in the same position. Prev and temp will be in same position, but when we move temp, for the first time prev will not be moved. It means that temp is moving, prev is moving behind the temp. So this is how the traversing is happening. So when temp is at this specific node, that is temp is at 30, prev will be in 20. So prev is moving behind the temp. So in order to bring this specific concept, let me have here as prev equal to temp. So prev is moving behind the temp. Now this node has got the value. So let me remove this question mark. Now it is easy for me to mark null to this node, so that this 30 will remove. So to delete it, just having prev of next equal to null, the last node will get deleted. This is how the pop operation will be carried out. But at each and every case, we are going to consider all the boundary condition. So when we look into a boundary condition, if we have a single element, only if we have an element like 10 is alone present, 10 is alone present, start, temp, prev, all these three nodes will be pointing to a same node, right? At this case, when we go with this sort of code, it will not work, because we don't have anything to tell about the next of temp and prev, all such things, because all the three nodes are pointing to the same case. So here you are supposed to handle a special case like if start of next equal to null. If start of next is equal to null, then just make start equal to null. If you are going to do this, then if you are having a single node, then this will work. So this has to be done before all these set of statement in order to remove a single node. So these lines will remove some set of, when we have a set of nodes. But if you are having a single node, then this specific code will be working. Right. So to sum up this specific lecture, what we had a discussion is the linked list implementation of stack, where we discussed about SMT, push operation, pop operation, and also we have discussed in detail about each and every operation, having with the algorithm as well as the implementation with one example. In the next video, we will be discussing about the applications of stack. Thank you.